So welcome to our lesson. Good morning, Melanie and Belinda. EC programming. I want us to proceed from where we left yesterday. Hope you're getting me. Melanie.
Yeah,
Okay. Belinda.
yeah.
Okay. So today I want us to discuss flowcharts and pseudocodes in C programming in relation to program design and development. So directly to that topic, I want to present I want to share the screen with you. So confirm you can see the screen. Can you see that?
Yeah.
Okay. So when it comes to algorithms, these are a set of steps that we use to perform a given operation. And in programming, as an algorithm can be represented using a pseudocode or a flowchart. A pseudocode represents English statements that are duplicated when it comes to flowchart. But now flowcharts we use visual diagrams that has specific symbols with specific meaning. So these symbols include the first one is a terminator. The terminator represents start or end, an end of your application where you have your flowchart. So you have start or stop or begin or end. Anytime you want to have that in your flowchart, you will start with the terminator. Then the process, that one is the activity that is carried out within that particular flowchart. We'll be using a rectangle. Next, we have an arrow. An arrow will join these symbols. So we have left, top, different kind of arrows, depending on the kind of symbols you want to join. Next, we have the decision. In programming, we can call it a kite. A decision involves a case where you'll have yes or no output or true or false outcome, where there is selection or repetition in terms of looping. Selection, that one we'll discuss also next week. We have single selection, double selection, and multiple selection. So anyhow you have to make a decision within your application, you are supposed to use a flowchart. Next, we have input or output. That one we use a parallelogram. It represents a data entry or a display, input or output from your flowchart. Next, although subprogram is not commonly used, you know you have a subprogram. Yesterday we said structured programming involves submodules. So where you have to refer another given subprogram, we'll use that symbol which is at the end there. So those are the key symbols that we'll be using. Next, uh, let me show you more symbols before we start having examples. Those are more symbols. Flowline, that one I've mentioned. Stop or start, terminal, input or output for an input within your flowchart and the results that you expect. Then processing also is there, decision. So there are two symbols that I want us to add, on-page connector and off-page connector. So where you have symbols in one page and you want to join them, mostly when you're using the flowcharts, avoid flowline cutting across each other. So in between, where you have lines that intersect, you use an on-page connector to avoid line cut closing each other. If symbols are on different pages, you'll be using off-page connectors. Anyone with a question in relation to the symbols? Okay, if no question, let's start with our first example there. A flowchart that will add two values entered by the user. So I'll directly apply or use the symbols that I've shared with you. So the first one is a terminal where you have start. Then you declare, that one is now a process. A process we use a rectangle. Declare your variables. We have num1 as a variable, num2 and sum as a variable. So read the two variables. Now this one is a parallelogram, and we have said input or output, we use a parallelogram. Then from there we'll have a process. We are initializing our variable here, sum, that we have declared. Initializing is given as a plus b. A is num1, b is num2. Then we displaying. We are using a parallelogram to give out the results. Then at the end you terminate with stop. That's our first example. I've used the exact symbols that I've shared with you. Then example 2, a flowchart to input two values from a user and then display the largest of the two. Now here we'll have a decision, we'll see. So you'll have start, input the first value. Input the first value and num2, you can combine the two. Like now, first example, the two are in the same parallelogram or the same symbol, or still you can split. Still it's okay. Then you test. This one is a decision. The one I call a kite, a decision symbol. So num1 is greater than num2. So anytime you have a decision within your application, the outcome is either true or false or no or yes. If the condition is true, you'll have a specific outcome, and if the condition is false, the alternative outcome will be displayed. Now here we have entered two values, num1 and num2. So our decision, num1 is greater than num2. If that is true, automatically it means our application will return num1, and we are using a program to display that symbol. Then if our condition is false, we'll have this symbol to display our num2, meaning that's the maximum value. Then we use a connector. Now that this is where you'll apply a connector to join this symbol and the other one where we have display num2. To avoid these arrows cut closing each other, you use an on-page connector. This is an on-page connector. Then from there, you stop your application. Advantages and disadvantages, I will share with you those notes. From there, let's have more examples. More examples. This example 3. Draw a flowchart to add two values entered by the user. So this one we had it, still is okay. I won't repeat again. A flowchart to check whether a number is odd or even. Still here we'll have a condition. So start. Here you can have start or begin. Any can do. Then input a number. We're only entering one number. And I want us to be very keen with the symbols that are being used here. So start, input a value. So if the number that you have entered, this is now our condition. Percentage in C programming means modulus. That value, the moment you divide by 2, the remainder is 0. So if that value you have entered modulus 2 is 0, the outcome can either be true or false. Or you can use yes or no. Any can do, no one will penalize you if you use yes or no or false or true. If our condition is true, if that value you have entered modulus 2 is given as 0, meaning our condition is true, the outcome will be that value is even, display even num. But now if that condition is false, it will display odd num. So the key concept here that I want us to note, in C programming, this operator modulus means that value divided by 2, the remainder is 0. Still here, where you have equal sign, if I change my condition, I use number modulus 2 is not, I use exclamation mark. Exclamation mark equals to 0, is not equals to 0. If the condition is yes, that one now becomes an odd number. Alternatively, the other side will be even number when I change my condition. So that is example number 3. Next, draw a flowchart to find the largest among 3 different number entered by the user. So here we'll have 3 values and we test the maximum value among all the 3. So we start with the terminal, start or begin, then that is our flow line. Declare or input all the 3 variables. We are testing 3 integers. So I'll have to input the three integers. And it's not a must use A, B, and C. Can use any variable name of your choice as long as you follow the variable naming rules. So declare variables A, B, and C. That one is a process. Then the reason why we are calling it a process, you are declaring a variable, a memory to store the values that will enter. And that's why the next step you are supposed to input. I'm using a parallelogram. Enter or you read the variables that you have declared up there, A, B, and C. Now here, I want us to be very keen. We see how the condition is being tested. I've entered A, B, and C. Those are three integers. But for a start, I'm testing two values, A and B. Is A greater than B? That's my first condition. If that is true, now it means the other side I'll focus on A and C because A is already greater than B. But if my first condition is false, A is greater than B, I'll focus on, I'll concentrate on B because my condition is false, meaning B is already greater than A. So I'll test B and C if my first condition is false. But if my condition is true, I'll test A and C. Then if condition 2 is true, meaning A is greater than B and also greater than C, automatically it means the maximum value there is A. If A is greater than B, and here the condition A is greater than C is false, it means A is not a maximum value, and also here A and B, B is not a maximum value, and also A here is not greater than C because it is a false condition. But the other side, if A is greater than B, false, meaning B is greater than A. Now I'll test B and C. B and C. If that is false, automatically B will become the maximum value. But if that condition is true, automatically C will become the maximum value. Why? Because A is not greater than B, and also B is not greater than C. So C will become the maximum value. Alternatively, you can combine these three conditions. Instead of having condition 1, condition 2, and condition 3 here, you have 2, 2. Still, this one is okay. That is example 3. Example 4. The next example, this one we are using looping a flowchart to find the sum of the first 50 numbers. That one is a loop. And in C, we have three types of loops: for loop, do while, and while loop. I will discuss that in our next session. Here, they have used begin. I've said others will have begin and others will have start. Any can do. So that's not an issue. So begin. Then the other one is a process. You initialize. Number one is the first variable there. You're initializing to, you want it to start from 1. Our question here is a flowchart to find the sum of the first 50 numbers. So you have to start from 1. Then sum you initialize to 0, meaning the moment you are starting, the sum is 0. So this is our condition. The number must be less than 50. So if that is true, our sum now will become sum plus number. The sum that we had initialized as 0 plus our first number as 1. Then because it's a loop, a repetition, the number will be increased by 1, meaning the other number will be 2. So 2 is less than 50, true. You add the sum. You add 1 again, it will become 3. No, 3 is less than 50. So this one is a cycle, a looping, a repetition, until a time when this condition will become false. Assuming when we'll have 51. 51 is less than or equals to 50. That one now our condition will become false. And if it is false, it will display our sum, and our flowchart will end. So I've said, and here you can have end or stop. Any can do. There is no any issue with that. Now let's have pseudocodes. Anyone with a question? Melanie? Belinda? Anyone with a question? Okay. Now let's have the pseudocodes. A pseudocode is an English-like statement, or these are English-like statements that represent an algorithm. For example, here, a pseudocode to add two numbers. So I want us to follow what is here. I start with begin. You can have begin or start. Then this is declaration. S1, number one, number two, and the sum. So input number one. So here you don't use diagrams. These are just English-like statements or English description of an algorithm. Then input number two. This output means what will be displayed on your screen or your application the moment you execute. So input number one, you enter S1, the variable that you have declared here. Then input number two, S2 is there. Then sum is sum1, S1 plus S2. There are two variables, then you display the sum and you end. Pseudocode 2 to calculate the area and perimeter of a rectangle. So these are the variables B1, B2, area and perimeter. So input B1, meaning length, and the other one width. Still it's okay, you can use any variable length. So area is B1 times B2. You multiply the two variables you have entered. Perimeter, the two length plus width times 2. That's the perimeter. Or you can say B1 plus B2 plus B1 plus B2. From there, display your area and display your perimeter. Example 3, area and perimeter of a square. I'll enter the variables, length, area, and perimeter. A square means all sides are equal. That's why I'm only having one variable here, length. So input that length. Area will be that length squared. Then the perimeter, that length multiplied by 4, or length times length, times length plus length plus length plus length, meaning the same as times 4. Then display that area and display that perimeter. Then example 4, the area of a circle using a radius. So you'll prompt the user to input that radius, and we have area variable. So input L, area is given as pi r squared, that r that you have entered here. Then you would put your area and you end. Where you have begin, end, I said you can have start, stop, any can do, and no one will penalize you for that. Then pseudocode number 5, perimeter of a circle. Perimeter is 2 pi r, or same as pi d. So the moment you enter the radius here, it is that radius times 2, you multiply by pi. Then you display the perimeter. So let's have example 6. Example 6, to calculate sales taxes. So this one I want us to be very keen to calculate the sales taxes. You begin, these are the variables: price, tax, tax rate, and total. So enter the product price. You enter the variable that is there, then enter the tax. So that tax will have to divide it by 100, assuming it's 5%. So the tax that you are supposed to pay. So if that item or that commodity cost 40K, you'll say 40 times, and the tax rate is 5 times 100. So how much are you supposed to pay? The price you plus, or you add the tax that is added, and the tax you have said is the price of that item multiplied by the tax rate. Then display the tax and the total amount. So that's okay. Then example 7, we have a condition. A condition. I want us to be very keen here. We see how we test. Here, a pseudocode to test if a driver can get a license or not. So assuming the condition is for you to get a license, you must be 16 years and above. So enter the age. The age is there. So we have that variable, enter the age. If that age is greater than or equals to 16, the output will be you can get a driving license. If not, meaning our condition is false. Else means alternative. If your condition is false, you cannot get a driving license. This is where, if you are drawing a flowchart for this, you must use a kite, a decision, meaning the outcome or the condition can either generate a true or false outcome, or yes or no. Then example 8, example 8. Here, we want to check if a number is positive or negative. Which condition do we apply? If any number is greater than 0, that value is positive. That is what I'll use as a condition here. So you have two variables, and only one variable num. Enter that number. If that value is greater than 0, then the number entered is positive. Else, the number entered is negative. Anything less than 0 is negative. Anything greater than 0 is positive. And if you enter 0, the outcome will be entered number is 0. This is a good example of multiple selection: if, else if, and else. And we'll do that practically as we continue. We'll have to write some codes. So I only have two examples remaining. Example 9, print numbers from 1 to 10. This is where we use a loop. So you'll have a first number, so enter the value there. You can initialize or you input. And now here it is, they have given us the range 1 to 100. You don't have to input. So I've just declared the variable. So for that variable starting from 1 to 100, step 1 means you are adding 1. So from 1 you'll have 2, from 2 you'll have 3, from 3 you have 4, and so on until the condition is met here to 100. So anytime the loop is added, or the loop here, we have step 1, from 1 to 2, you display that value. Then you end the loop. Then our last example, number 10. To find sum of natural numbers from 1 to 100. So here you'll see it's the same thing as example 9, but we're adding another variable called sum because we want the sum of those values. So begin, I've added some variable and initialize to 0. And if you can remember, we had a variable, we had a flowchart where you are calculating sum, and we were initializing to 0. The reason why I initialize to 0 is that your application will start from 0. So counter being a variable, sum is 0. For 1 to 100, step 1. Within that loop, you increase your sum, meaning the new sum will be sum, that the one here is 0 plus counter. Our first counter is 1. So meaning the new sum will be 1. The counter, or our loop now will jump from 1 to 2. You increase the sum again to be 1 plus 2, to be 3. Then the loop again adds 1, 2 to 3. So that process continues until the condition is met. Here you have to 100. Then you would put your sum and you end here. You end your pseudocode. So anyone with a question? Anyone with a question? Melanie? Anyone with a question?
No.
Belinda?
Yeah.
Any question?
No, I'm good.
Okay. Melanie? Okay. I'll share this video with you so that those who are not able to attend today's lesson will access the content and be up to date. They get what we shared with you today. I'll share the audio and video of this, and also the summary notes. I'll summarize the content and share with you. So if no question, let's meet tomorrow. Is that okay?
Okay. Yeah.
Okay, Santi. Thank you. Have a nice day.
You too.